Hello and welcome everyone. Thank you for joining us today for our webinar titled The Conversation That is Key to AI Success. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Dr. Ellen Friedman is a technical evangelist at H2O.ai. She's an author and speaker on machine learning and issues related to large-scale data and computing. Now, before I hand it over to Ellen, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. And without further ado, I'd like to hand it over to Ellen.
Hello, and thank you all for joining us. Thank you, Patrick, for that introduction. What I want to talk about today is a conversation, so I want to have a conversation with all of you about it. And it's a conversation that's absolutely essential for AI to be successful, to be practical in practical business settings. So let's jump right in. This is my contact information, and do feel free to contact me. I'll also repeat this slide at the end of the talk, so you can check it out then as well. Now, the question is, what is the single biggest challenge for AI to be successful? And I mean really successful, useful, not just whether a model itself works. And it turns out the biggest challenge, the biggest barrier to success is finding the right business goal. It's really important to remember that AI, while it's very technical and requires great expertise, is actually a business process. And as any other business process, it needs to work in the context of the overall situation. It needs to be attached to a practical and addressable business goal. You have to have, obviously, the right data to use in order to build and train your model and run your models. But you also have to have a way to connect that results, whatever your AI system is telling you, whatever your models are telling you, a way to connect that to the real world, basically, to take action. And just a report is not an action. So usually that involves building an AI application. The AI application itself may not be the end goal. That may need to be connected to some other business process or target, and you need some way to understand that that's happening. When this happens successfully across this whole chain of events, that's when AI really begins to be successful and to pay off. So whose responsibility is it to be able to do that, to be able to put AI, to not only build the models, but to put it into a proper business setting? Now, AI and machine learning are exciting areas. Data science is something that's very attractive to people. In fact, people tend to see the AI expert as a bit of a superhero. She or he has very specialized knowledge to be able to build and use and tune algorithms, build models, and so forth. The question is, are they also supposed to know, for example, what's important about blueberry production? It turns out a company called Hortifruit is an H2O customer, and they're using AI in very sophisticated ways to predict changes in supply and need, and how to pick the blueberries at the right time based on both their development and supply. Should the data scientists actually have to be a specialist on that as well? And in addition, because this is applied to many different areas, should the data scientists also have to be an expert in utilities and large-scale industrial settings, banking, financial, research, science, healthcare? Of course not. One person can't know all of this. And so whose responsibility is it? You usually need to rely on people who are actually domain experts. They have domain knowledge. And then, of course, from the other side, is a domain expert supposed to be an expert on all the aspects of machine learning? No, that would be unreasonable. Now, you certainly have overlap, but the point here, the message here, is that for this to really work, you need a combination between AI expertise and people who have real-world domain knowledge. And it's those two groups working together that make these systems really powerful and make them really work. Let's take a simple, incredibly simple example. It actually works in the real world, to look at just for a moment what I mean by domain knowledge and why that matters so much. So using AI or machine learning as a part of building a fraud detection system is pretty common, and credit card fraud is one issue that's been looked at for a long time. It actually turns out that one thing that you can look at with these systems is to discover a change in behavior. A person who's stolen a card may realize that it's actually easier to fake a signature than to actually know or fake the PIN. And so they start to use the card as though it's a credit card where they can actually use a signature. What an AI system can look for is that change in behavior, because the card user normally isn't using a signature. And the key here is that the AI model doesn't have to determine whether that signature is real or fake. They have to look for a change in behavior. But whether it's the financial industry, credit cards, banking, other industries, retail, large-scale industrial systems, it's the people who have domain knowledge about that system who understand what are the behaviors, what are the issues that point to the changes that AI models can look at or make decisions about. And so it's a combination of being able to build those models well and have that domain expertise. The point is, you don't have to be a data scientist to be an important and valuable member of an AI team, of an AI project. If you have that domain knowledge and you're working well with data scientists, you're really contributing to the project. And I want to remind you that domain knowledge, domain expertise includes business expertise, people who understand business itself. The very best AI involves cross-skills collaboration. Now, this is a real-world example with a very large industrial company, and they are using machine learning in a wide variety of different ways. They have IoT sensors on various large equipment out in the field. They're collecting tremendous amounts of data. That data is being processed in various ways, most of it back at core data centers using machine learning and AI. And they have some very sophisticated data scientists working on this. But it was actually a conversation between data scientists and people in their business area, in their accounting area, who discovered another application for AI, and that was to figure out that there was a quick win to be had, that instead of all the sophisticated IoT sensor data, all of that was happening also, they figured out that in accounting, every item, every service, every part had to be accounted for, and sometimes the codes were entered incorrectly. And when that happened, revenue might be lost. It might be something that was supposed to be reimbursed by a client. It might be something that was tax deductible. But it was too hard to go back in manually and find those mistakes and correct them, because it was actually a very tiny number of mistakes among a very huge amount of information. But by building an AI model that could actually enrich the target, it could say this subset of invoices are ones that look like they're more likely to have an error. Then it made sense for humans to go in and do the assessment and actually make those changes. And within a very short period of time, this company literally had a return of tens of millions of dollars based on using AI in this situation. The point here is that what really paid off was the business knowledge and the conversation with the data scientists to understand that that was a bottleneck, that was a point that could be targeted, that was a decision that could be enriched by a combination of AI and human decisions. And in fact, the models that were built to do this were incredibly simple models. And so the sophistication was actually in terms of the conversation between those two groups, those two types of expertise, rather than the complication of the model. The conversation itself is absolutely key. So there are four big ideas related to the conversation that I want to talk about with you today. And we've already talked about why this matters. Let's jump to the next idea, which is what needs to actually happen in that conversation. And one of the things that needs to happen is that people need to dig down and figure out, once they have addressed a business goal, they know what they're trying to answer, they need to figure out what data is appropriate? And by that I mean, what data will reveal the kinds of behaviors or events that are what are being addressed by the AI system? What form or format does that data have to be in order for it to be able to interact with an AI model, or indeed to train an AI model? And then it really raises the question of, do you have that data? Do you have it? Do you have permission to have access to it? If you don't have it, can you collect it? And let's take this example once again, thinking about fraud or an attack, maybe on a website, a credit card fraud, it doesn't matter. But think about how timing comes into this. It's not a single event. You're looking for multiple events, usually hundreds or thousands of events. Here we're showing 3 users. And the question is, from the point of view where you are now, there's a point at which fraud actually occurs. You see that at different points in the timeline for these different users. There's some point after that where you're able to detect fraud, meaning there is some behavior that can be looked at to make that detection, and maybe that's what your model is looking at. And obviously, the shorter that timeline is, the faster you can actually detect the fraud, the more likely you are to reduce risk or loss. But another question about do you have the right data is often there's some behavior that precedes the fraud, and that behavior may signal a possible fraud, and that lets you actually have intervention or prevention at an earlier date, even before the fraud occurs. But then the question is raised, do you actually have data to cover that event? Is it a behavior that you can watch? Is it a behavior that you've actually got some history of data for? If you don't, can you start collecting it? Those are the kinds of questions that need to be part of the conversation between the non-data scientist and the data scientist. Another issue or issues have to do with time. So some of the questions you might ask, some of the topics that should be discussed in that conversation is for a model to work realistically and actually deliver value, what is the timing? What is the latency that's acceptable for the model response? So now we're talking about the behavior of the model, and the AI expert can give feedback and talk about the model and how it might be tweaked to make it faster. But the question is, how fast is good enough? How fast works within the need for whatever response or action you're taking? And if you get beyond that, it's really just basically bragging rights. So you want to make that realistic. Another issue of time is to say, as you start one of these projects, how long does it take to actually develop the models? And faster model development is usually a very good thing. It not only means that you can try more things, but often it means you can get to a solution faster. And some solutions are really sensitive in terms of external events. Boy, if 2020 has shown us anything with the huge changes that have come up because of COVID and the many changes and adjustments that people needed to make in their processes in response to a world that changed, this is where AI and machine learning really shine, because they're adaptive systems and they give you flexibility. But in this case, there were real-world external events that put an urgency on changing and redeveloping and retraining models. And so finding out how long that model development has to take and what can be done to improve that is an important part of the conversation. Related to that is, how long does it take to collect the right data? If you don't have the data, or the data is looking at certain time periods, you need to factor that into the whole discussion. And because we're talking about AI as a business process, AI that needs to actually show some impact on business, a different question, and indeed often a much harder question, is to say, how long will it be before realistically you would actually see a change or see an impact on the business that's measurable? And understanding whether a system is working, understanding whether the AI models need to be adjusted or trained or retrained, is not just looking at the model performance itself on evaluation data. It's looking to see whether the whole system is having the impact that you want. And if it's not, to, again, have that feedback into the conversation. So all of these issues are ones that should be brought up as these groups talk to each other. it's really important to understand how it fits into that whole conversation, into that whole process of connecting data used to train a model, building the model, looking for model performance, the applications that are built to actually act on those insights, and how that connects to an end business goal. And so, of course, you can't really know anything is working unless you can actually measure it. And so metrics at all of those points are important. And when you think about it, these are very different kinds of metrics. The metrics related to the model, the AI system itself, are looking at how efficiently or accurately the model reacts to new data and comes up with solutions. Are those solutions appropriate? You can look at performance for an application to say, is the application running? Is it running properly? Is it running with the right latency and response time? Is it returning meaningful information? Is it connected to what it needs to connect to? The even more complicated one are those last metrics, which tend to be business metrics. And sometimes those are harder to have something that's measurable and realistic to say, because there are other factors that are going on related to whatever business event or goal you're looking at. But trying to say, is there actual lift? Is there actual change? Are you getting the kind of result or impact that you want from the AI system? Is it making a positive effect? But all of these are really important, and deciding that ahead of time, what's measurable, how will you measure it, when will you measure it, again, is a very important part of that conversation between the AI experts and the business experts or domain experts. So what needs to happen in that conversation, we've talked about most of these issues of the bullet points already, but that last bullet point I want to call your attention to, keep in mind that all of this can be thought of in terms of just engineering basics. You have to be realistic. Data scientists, in fact, are not magicians. They need to have reasonable resources. They can't always have all the resources they want, but they certainly need to have reasonable compute power. They need access to the technologies, the AI technologies that they find most useful. You have to think in terms of, are you providing a reasonable amount of time for development of the project? And remember, the development of the model itself is actually only a small part of an AI or machine learning project. The logistics of handling data, processing data, making that data available as training data and so forth is a huge part of the effort. And to be able to say who is going to get this into production, whose responsibility is it to maintain these systems once they're in production, how do you get that feedback once models are running in production to say, are they still working properly? Is there drift? Sometimes the model is working fine, but the entire world changes, and it doesn't always change as much as it has in 2020. But the world will change. That's inevitable, and that's part of the strength of AI and machine learning, is that those systems can respond to changes because they are literally being informed by data and can be changed and updated and retrained. But you have to have somebody who's responsible for watching what's happening, evaluating, and deciding when that's appropriate. So figuring that out, making sure that people know who's watching the store, basically, again, is an important part of the conversation that happens between these groups. Also want to remind you that AI is an iterative process. As models, and it's not a single model, as models are developed, as many different approaches are tried, as they're evaluated, trained, tweaked, reevaluated, finally seem to be performing well enough to be deployed into production, they need to be continued to be monitored and sometimes retrained or new models put out. But we could really expand this process beyond just what's shown in the little diagram to say there's an iterative process in terms of the whole business setting as well, in terms of what data are available, what business goal is being targeted, is it being addressed properly, are there new lines or new variations on this project that maybe a project is very successful and that opens the idea for new projects. And so the entire process, including the business part of it, are iterative. that means the conversation that I'm talking about today happens in layers. It happens over and over again when it's working very successfully. So we've talked about why the conversation matters. We've talked about some of the things that need to happen during that conversation. Why is this difficult? Sounds like it should just be easy. What are the challenges? What makes it difficult? And the simplest answer to that is it's difficult because it involves people. But the point is, it involves people who have very different expertise, very different experience. They have a different understanding of situations, which in fact is a strength. Bringing in different points of view is what makes these systems work better when that's done well. But it can be a challenge or a barrier, especially since they often speak different language, they have different jargon, different terms, and even common expressions can mean different things to people with different backgrounds. So that's part of why I wanted to talk about the conversation today and what can help to make it work better. This is not just a touchy-feely, everybody should feel nice because they had a nice conversation. This is an absolutely critical part of a highly technical and highly complicated process. If it doesn't work properly, things tend to go wrong. Data scientists aren't working with the right data because they have been misinformed or don't understand what the data is, or they're not looking at the behaviors that actually address the issue of concern. The people who are requesting that these systems be built may be making unreasonable expectations. And I'm pausing here. I see there's questions from the audience, and they may be from a little while ago, but it looked like there was an issue with audio. Do we still have audio?
Yes. No, it's
cool.
been solved.
Okay, I should have noticed it earlier. It's pretty funny if I'm talking about the importance of the conversation and that the audio cuts out.
No worries.
I guess
and
I
just
should.
Just a reminder for everyone on the line, if you have questions for Ellen, please start typing them in. We're going to leave time for Q&A at the end.
Okay, so I guess I can add a bullet list here, especially in today's world where so many people are working remotely. Maybe the conversation is also difficult because of lack of connectivity or when Zoom connections go down. Back to serious for a moment. It really is an issue for people to approach this conversation well and make sure that it works. And people on both sides of that little barrier can actually feel anxiety over it. It may be that people feel anxious about talking to an AI expert because most people don't have the depth of their technical knowledge. They're not as comfortable with advanced mathematics and so forth, and they just feel uncomfortable talking to people who are experts with this. Some data scientists are uncomfortable talking to people who don't have those expertise, people who are in very different fields. It just feels like an awkward conversation. And being quite frank here, because of that, sometimes there's also a lack of mutual respect between these groups. And I think a good starting point is to recognize that they both have knowledge that's incredibly valuable and absolutely essential for these projects to work. And so these are some of the barriers that need to be overcome in order to make these systems work. That barrier, that interface between non-data scientists and AI experts really can be a daunting block. And if it's not removed, you end up with AI experts building beautiful models that are kind of working off in an abstract world, and they're not connected into the real world and delivering the very huge potential that they really can deliver, the very big impact on business and research systems. So we move to the last big topic of this discussion today, and that is, how do you actually overcome those barriers? If you take the conversation seriously, you know what needs to happen during the conversation, you're kind of aware of some of the challenges, but how do you get past that? And there's no single answer. But I want to give you some examples, just some very practical, down-to-earth things that you can do, whether you're a data scientist, a business leader, domain expert, whoever you are. If you're involved in these projects, these are some of the specific and practical things that you can do to try to pull down that barrier. This is not everything that helps, but thinking through this, these are some things that I've seen that make a difference. One thing is getting consensus among the stakeholders. When people on all sides of the issue actually know realistically what AI can do and should do and needs to do, when they understand why the conversation needs to happen and again happen over and over again, they know why that conversation matters, they're more likely to join into it and address it well. So just recognizing the importance of the conversation is already a huge step toward making it work. People on all sides of the issue need to come to the table with confidence. They need to understand that they have valuable knowledge. They don't have to have the knowledge of every aspect of the project, but they're bringing something to the table that matters. They also need to be respectful of other people, to recognize that they're coming in with different information. But what I mean by insist on communication, people on both sides of the issue really have to demand of themselves and everybody else in the conversation that they really break through the barriers and make sure that everybody understands what's going on, that they are exchanging the right information. Because without this, a huge amount of time and effort can be lost. And so keep after the conversation. Make changes in it. Insist that it work. Make sure that you understand that you've gotten the knowledge and the information that you need. Make sure that you've been heard and understood. And again, with respect, people need to understand why somebody keeps coming back at them with more questions. It's not to say they think they're wrong. It's to say we may not be clear. We may not be hearing the same thing from the answers. Part of what makes all of that work better is to learn ways to translate what you know, what you need to convey, into terms that are clear to the other parties. And I do not mean, I sometimes have heard people use an expression, if you're talking about highly technical content to people who don't have that technical background, and they say, oh, you have to dumb it down. And that is the last thing on the face of the earth I would recommend anybody to do in a conversation like this. Instead, you want to smarten it down. You want to get to the essence of what matters and what you're saying. You want to find terminology that will meaningfully convey exactly what the other party needs to understand. You can begin to develop a common language within your own organization and kind of train yourselves to understand what some of these terms mean. Non-data scientists don't need to become AI experts. AI experts don't need to become experts in domain knowledge, but both of them will certainly pick up some understanding of the other side as they work together on these projects. And so that kind of translation into terms that work well in terms of the project is probably one of the most important changes or steps that you can take to make this practical. And you have to practice this. The more you do it, the more those conversations happen. And frankly, I think the more people get to know each other, it really makes this go forward in a much more productive way. So let's look at just some simple examples of the kind of thing. The example itself doesn't matter, but I just want to give you a flavor of the kind of thing I'm talking about. We talked about people building systems to detect fraud in various forms, credit card fraud, so let me use that example again. And what I mean by translate is whichever side of the issue you're on, realize when somebody says something, what that means in terms of your background in language. So for example, you're figuring out how somebody who is committing credit card fraud, what are their behaviors, what do they do? And the background here is that they often make small transactions to sort of test out a card to make sure it's a valid card, to make sure they have enough information to use it. And they do those on small transactions that might not be noticed before they really start to make, big and expensive transactions. So in the conversation that we're talking about, a domain expert might say, fraudsters often do a probe transaction at a gas station just before making big fraud transactions. That's an important piece of information. The data scientists who are going to build a system, when they hear that, what they need to hear, when they hear somebody say gas station, they think merchant type because maybe they're building a risk table. When they hear somebody say just before, they need to find out a little more about what time period before the large fraud transaction, what's typical of when these probes happen. Do we have some known data that, historical data that can be used to train models and so forth. So translation isn't a big complicated thing, but it's a very important thing to make sure that each group understands correctly what data they're working with and what kinds of behaviors they're looking at, what's essentially being modeled. I mentioned that even common words can be understood differently by different groups, and just be aware of that and work with that. So something as simple as somebody saying, what model is being used here? The data scientists may think of some of those terms that you see on the left there, gradient boost, random forest, and so forth, deep neural nets. Whereas saying what model is being used, a non-data scientist may think of meaningful things, but not specifically those aspects of the model itself, but they're saying what behavior is being modeled. In other words, what is being modeled, or wonder about what data is being used. They may think what model is being used in terms of, is that a realistic situation and will it have business impact? And all of these things are important. They're just different. So be prepared for those changes in how people hear things. I said you have to dig down and make sure that the conversation works. Interrogate each other, and that's actually a good thing. And these are just some samples of the kinds of things you might ask. If you hear something that's too technical for you in terms of the data science, ask, can they restate that in business terms? Really dig into the behaviors or the surrogate behaviors that can give you insight into whatever is being modeled, whatever decision is being addressed. Make sure you understand the form that that data needs to be in. Look at this last bullet point. You may hear a data scientist talk about improvement in AUC, the area under a curve, and they may talk about how model is working so much better. That's a good thing, but you have to put it in context. If the model is working better, is more accurate, but if that extra accuracy really has no business impact, then it just becomes basically bragging. So again, it's just a conversation to make sure that you've thought about this in context and all parties understand what's going on. I think I'm running a little short on time here, so I'm going to speed up. I just had an example here. Imagine that you're working in a system for looking at supply chain for a large manufacturer. I know H2O works with a number of companies. I haven't been directly in their conversations, but here's a typical kind of conversation we could imagine. Maybe in this case, the business expert is asking a valid question, but one that's a little too general. They say, can AI improve our supply chain costs? So the AI expert now needs to dig down and get more information. Are we talking about upstream or downstream forecasting? Are we talking about different geographic areas? If so, which ones? This question, I think, is a really important one. How long in advance would you need to know this? If we're building a forecasting or predictive system, what's the time frame over which that knowledge is useful, and so forth. So again, just dig down, really expand the conversation, make sure all parties understand what's going on. You probably heard the term data ops, which really expands the concept of DevOps to add people with data skills. And this isn't just for machine learning, but it certainly applies to machine learning systems where things like the data engineering is a huge part of the system. It really expands that. And I would say this concept should be expanded even further to maybe include business ops, so you need to include the domain knowledge and the business understanding of the system. But the point here is that thinking about building cross-skills teams, and the team is aimed at a specific target, tends to improve collaboration. I mean, this has been shown in a number of situations. It improves collaboration. It tends to improve communication between people in different roles. People in different departments don't feel like they are being imposed on or asked to do a favor when they're asked to participate in a project like this. They feel like they are part of that horizontal, that cross-skills team, and this really makes development usually go much faster, be more on target. The results tend to be much, much better. It's a huge change in behavior to build teams this way. Now, we have a few minutes here at the end. Another thing that can help is technology can actually help pull down that barrier and make this conversation, indeed the whole process of building AI and putting it into a business system work better. So the technology itself can make a difference. And I want to talk about an example technology, which is one from H2O, but I want to talk about it in the context of why it makes a difference, not just obviously to build models and as an excellent AI technology and platform, but why it makes a difference specifically to the conversation between the non-data science and the data scientist. I'm going to use an example. AI has a number of systems that it builds. There's H2O3, which is a free open source system. The one I'm talking about now, though, is an enterprise platform called H2O Driverless AI. It has automated AI and machine learning capabilities. But one of the things it's really just a leader in is the ability to provide data scientists with interpretability and explainability. It has good visualizations. It easily doesn't just speed up the whole process, but it provides insights to the data scientist so the data scientist understands better what features are being used, how they're being weighted, what's making a model work and not work. And when that's more clear to the data scientist, it means they can try more things faster because they understand what's going on, but it also gives them a tool, a good platform for being able to explain this, to interpret it for other people as well. And so this is really a huge advantage of using a technology like this, is to have explainability and interpretability. This is just a quick look at, go to the website and look at it. It's hard to see here on the slide, but some of the toolkits that are available within this platform. But I just want to drill in on one thing, and back to the conversation that we've been having today. Say you're not a data scientist and you approach this conversation and somebody very helpfully starts digging in and they start talking about some term that you don't know. This is Shapley values. Maybe you don't know what Shapley values are. That's a point to stop. It's your responsibility to interject into the conversation. You need to ask what that means. Don't worry about, not knowing. There's no reason you should. You need to stop and ask. It's the responsibility of the data scientist to stop and explain in reasonable terms what the importance of Shapley values are. And this really can be done. I'm just using this as an example. It's important to understand which features or which variables are affecting model performance. You want to understand the relative importance of those features. And in this particular case, a Shapley value is a way that the data scientist can determine the importance of a particular variable or feature to a specific model and compare that to how that variable tends to happen at an overall or global level. And that's important in a business sense because it helps you understand if things are being weighted or overweighted. But it's just an example. These things can be explained so that you understand the significance of it. It doesn't mean you know enough to calculate or do all of it yourself, but you don't need to. And being willing to stop a conversation and say, wait a minute, put that in context for me, makes a huge difference. H2O, by the way, has a new platform, a new product called H2O Wave that is used to help you build the AI application. So that's that next step down the process of putting this into a good and meaningful business context. This is a really great thing. Go to the website, you'll see some examples of how this can be used, and there's more coming on this. But again, I think this is going to help not just the conversation, but the whole interaction between the domain experts and the AI experts. So all of these approaches, how you approach a conversation, learning to translate, approaching it with confidence, practicing getting really good communication, making use of technology to help you do that, are ways to pull down that barrier. And that's what needs to happen to really help ensure that AI projects work well, deliver impact, are really meaningful and valuable in a business or research setting. So thanks so much for joining this conversation. In terms of some next steps and things I recommend, go to the H2O website. You'll find a pull-down tab, or here's a link to look at their various business solutions. It really helps you, again, to understand how this might work in your own setting, to understand the kinds of problems that can be addressed, the kinds of approaches and the data that's used, and drill down into that. And do feel free to reach out and contact H2O. I'll give you a link at the end. That's one way to start the conversation, is talk to their experts and begin to understand whether the situations you're looking at in your own business are ones that could be improved by applying an AI or machine learning example, to see if that actually is something that can help, if it's practical. Some of the content I've talked about, and actually related content that helps you understand how to build out these teams and make this work in your organization, are addressed in this ebook that I wrote recently for H2O. They make that available as a free download of the PDF, and you have a link here to be able to do that. I think Patrick is also directly providing the links. And AI, H2O, yeah, thank you. H2O also makes available these two books that are long reports that are done through O'Reilly, and they're new. I think they're excellent. It's very hard to read the, I put such a small picture there, but this first one, Responsible Machine Learning, is done by Patrick Hall, Navdeep Gill, and Benjamin Cox. It's just excellent topic, and these are really experienced people. And the other book, Future of Analytics, I've had so many conversations with Dan Darnell, who's one of the authors, with Raphael Cross, and with Patrick Hall. And these are brand new, really excellent resources. Again, you can download these free from the courtesy of the H2O AI website. Please, whatever you do, continue to support women in technology. This isn't just good for women, it's good for society. And from one woman in tech, I say thank you very much for joining us today. Here's my contact information, and I've added the contact information for H2O AI if you want to reach out and open a conversation about your own AI projects or business goals. They have a lot of really talented people who will be happy to talk to you.
Okay, great. Well, thank you, Ellen. We have some great questions in the chat window. We'll try to get to all of them with time permitting. But folks, feel free to start asking your questions now if you haven't already. So just a quick housekeeping item here. Someone's asking, can you share the slides for the presentation? Yes, the slide deck will be posted after the presentation is over, maybe a couple hours after. So that will be available, as well as the links to download the 3 books that Ellen showed, and the Contact Us page on the H2O site. First question is, how can current AI students get involved with H2O?
Oh, that's an excellent question. And Patrick may have some things to add to this, but this is what I suggest. I suggest several different things. First of all, go to the website and look at some of the resources. They have some excellent tutorials. You may want to get started with the open source H2O3. So read about it, poke around with it, download it, try it out, look at the tutorials, look at the documentation. There's just a wealth of information. And I think that's a very good way to get started. H2O 3, the open source H2O, is used worldwide by tens of thousands of organizations. The other thing, and this is a great way to get involved, is that H2O has a very active open community worldwide. They had, until COVID lockdowns, in-person meetups really throughout the world. And again, you'll find on the website a list of where there are active organizations. Now, Patrick, you probably know better than me. I think that those meetups are still happening, maybe done as a remote meeting in most places now, and until we all get back to in person.
Yeah.
Do you know? Yeah. And I think that information is all available on the website. And I think participating with that H2O community is just a great way, not just to find out about H2O, but they're really rich conversations around using AI, and some of them are quite technical, but some are not. And again, you're going to meet people with a whole range of different experience from different sectors who are machine learning specialists themselves. Others are not. They're business people coming in, trying to find out more about what this can do for them. So that is just a wonderful way to begin to get involved with it and kind of see what direction you want it to take you.
Great. Thank you, Ellen. And I'll just add one last thing. We also have an exclusive academic program for higher education institutions for students and professors, where you can get a up to 6 months, I believe, free trial license of H2O driverless AI for research purposes. So that is available on our website to sign up. And I will be providing the link for that, as well as the open source community after the presentation's over. So we have plenty of resources for students. Now, the next question. Oh, did you have something to add, Ellen?
Oh, I was just going to say, I didn't realize you had that aspect of the academic program. So thank you. I just learned something. I think that sounds excellent.
Sure. Yeah, of course. Next question is asking, so it's saying the interaction between data scientists and domain experts is not going to happen as easily as explained in this meeting. Can't we make use of templates that someone already invented in a particular vertical, say supply chain, or do we have to reinvent the wheel?
Wow. It's a very interesting question. I think, let me address it on a couple of levels. First of all, if I understood your question, I don't mean to imply it happens easily. And if that's what came across in the talk, let me adjust that now. I'm saying those conversations are really difficult. And the things that I'm suggesting are ways to step in and actively change the nature of the conversation and begin to make them work. But it does require a great deal of effort. I wasn't joking when I said practice. Begin doing this and do it, and it's an experience that gets better and grows over time, but you have to begin to address it and understand that it really is a challenge. And so let me just clarify, I didn't mean to suggest that it's easy. It is very, very difficult. Now, back to the suggestion you're making in the question about templates. I think that's a very interesting question, a very interesting idea. Before we talk directly about templates, as people work with these systems, as they begin to think through what questions they would have themselves, the more experience you have, the sooner you get started, the better all of this works. You begin to develop an instinct about it, regardless of which part of the issue or what part of the experience you're bringing, and not just with regard to the conversation, but with regard to your own understanding about what systems can do, how do you look for bottlenecks, say, in a business that can easily be addressed by AI? How do you approach complicated systems? I just can't say enough about how much this changes as you begin to get experience with it. And it isn't just the experience of building and training the model itself, it's the experience of beginning to understand data and to understand the kinds of systems that respond. Now, that said, I think it's interesting to develop a template or a sort of guide. And it's actually something that's interesting. You mentioned it, that I've been working on with a couple of people at H2O to actually develop some guides. We hadn't at this point done it specifically for industries, but we're beginning to work on some guides that help guide the decision-making process, help guide you as to how to define and refine the questions that you're asking AI to address, and also how you approach the conversation. So yes, I think templates can be helpful as a way to get started, and again, as a guide, not something that should be rigidly adhered to. But I do think it's important to have human back and forth conversation. And I think one of the dangers of templates is if people feel like they just fill in it, even a very good template, they just fill it in on the one side and pass it to the other party, and there's never really a direct interaction and feedback and questioning back and forth. I think that can lead you astray. So I think templates are very good, but they should be something that helps frame and move a conversation forward. I think the conversation is still essential.
Great. Well, thank you, Ellen. I believe that does it for the questions that we have. I want to thank you, Ellen, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us as well. The presentation slides and the recording will be made available on our Bright Talk channel, and we hope you have a great rest of your day.
Thank you very much, and thank you all for joining us. I do hope you reach out with new thoughts and questions if you have them.